So to talk about and introduce the concept of density, I actually want to use a famous problem. It's kind of like a story problem. Though it's not been proven to be historically accurate, it's still a fun story. But density can be thought of in this way. So there was a king called Hero II of Greece, and he hired a goldsmith to essentially make him a pure gold crown. And he gave him a fixed amount of gold to begin with. And the goldsmith went about making the crown. When the goldsmith was done, he presented the crown back to the king. But the king was suspicious of the goldsmith, and he suspected him for replacing parts of the gold with like something cheap like copper, and then just plating it with gold and pocketing the rest of the gold. So the story goes, he hires Archimedes to essentially conduct a scientific experiment to determine if the crown is pure gold, because he doesn't want to smash it or wreck it. And what Archimedes does is really brilliant, as the story goes. So the idea is that the king gives the blacksmith 1,000 grams of pure gold. And gold, as a pure element, pure substance, has a known density. Gold's known density is 19.3 grams per centimeter cubed. Now you'll notice the units we're using here are not kilograms or meters. That is okay. It actually kind of relates a little bit, but we can use grams per centimeter cubed if everything kind of stays in the same units. So for this problem, we're going to be working in grams and centimeters. And so the idea is he places the crown in a bathtub of water. But for this case, on purposes to make the math a little simpler for us, we're going to use a little bit more of a uniform shape. I'm going to use a cylinder. So like some cylinder jar. Here's our cylinder jar that has a radius of 10 centimeters. And we'll say that the water is sitting without the crown in it at a height of 30 centimeters. All right. And when he places the crown, I'm so good at drawing crowns, in the water, it increases the height to 30.32 centimeters. And using what we know about density, we're going to calculate if that means that the crown is pure gold. So I'm going to move our image down there. From the density equation, so we use what's the Greek letter called rho. That's just the letter we use to denote density. It is equal to the mass divided by the volume of a substance. So in this case, I'm going to solve this for the volume by multiplying the volume to both sides and dividing the density. Or a shortcut is these two can swap places. I get that the volume of a substance is equal to the mass of it divided by its density, which in this case, the king gives him 100,000 grams, and let's say that he knows he gets exactly 100,000 grams back, right? So the mass in theory would stay the same. We get 100,000 grams divided by the density. That's 19.3 grams per centimeter cubed. The grams will cancel. I have centimeters in a double denominator, which we know becomes a numerator. This then becomes 51.8 centimeters cubed. Okay. Let's calculate what this would look like if we were to dip a pure gold crown into a vat of water, or essentially something like that. So the idea is that before I dip the crown in, it reads at a height of 30 centimeters. To understand this, we need to figure out what the volume is and the volume difference. So for a cylinder, I should do V here. The volume of a cylinder can be defined as the area of a circle, pi r squared, multiplied across the height of the cylinder, h. In this case, I'm not going to multiply across the whole height of the cylinder. I'm just going to multiply across the height of the water, because that's the thing that's going to change in volume. I want to know how much volume of water do I start out with. So this is going to be pi, the radius is 10 centimeters. I'm going to just keep this in centimeters. This is squared times the height. Water sits at 30 centimeters. This is going to give me a standard base volume of 9,424. I'm going to use decimals here because we want to be fairly precise. Say 778 centimeters cubed. And what we would expect if I had pure gold is to increase the volume by this much. So the new volume would equal this 9,424.778 centimeters cubed plus the 51,000.8 centimeters cubed. That would be what we would consider our new volume. And I would get a volume of 9,476 again, keeping decimals, 578 centimeters cubed. So what does that mean in terms of the height? Because right now, currently, we've only denoted that the height increased. I go back to my volume of a cylinder equation. The radius of the cylinder hasn't changed. Pi hasn't changed. So if my new volume is going to equal pi r squared times the new height. So I'm going to divide pi and r squared. My new height is going to be this new volume I calculated, divided by pi, and the radius is going to be the same, r squared. So in this case, I have the 9,476.578 centimeters cubed divided by pi times 100. This would be centimeters squared. The centimeters cubed cancels the centimeter squared, leaving just a centimeter, which is completely fine if I'm expecting just a height would be just in centimeters. So my new height, is going, once I calculate this, to equal 30.1649 centimeters. But we noted that the height actually increases to 30.32 centimeters. So it's subtle, but the height jump or the height distance is about twice that what we should expect. So by this conclusion, the blacksmith cheated the king. He did not use pure gold. He would have used an alloy of which we could figure out what the density of this alloy is. So we can actually calculate the density of this alloy for the height or the volume increase. If I were to use the same, I'm going to kind of do this quickly, but you can pause the video and do this on your own. If I were to do the same method, though, for volumetric increase from the height, the change in height is going to give me an overall increase volume of 100 centimeters cubed. The density of this unknown metal, which is probably an alloy, if it's coated in gold, an alloy is just kind of a fancy term for mixed metal. It's not a pure element. So we'll say this alloy metal is going to be, the mass is still the same, but now it's divided by this new increase. And what I get is that this one would have a theoretical density of 10 grams per centimeter cubed, which would be pretty standard for what I would expect to be like a copper gold alloy, like copper plated in gold, something like that. So a cheaper metal that looks as fancy, but isn't actually pure gold. So king should definitely have a word with that blacksmith.